All right, 5.3b, trig equations. So this first one, I need to find all the solutions of 2 sine squared x minus 1 is equal to 0. And now I have a domain restriction. I'm on the interval 0 to 2 pi. So what is this sine squared thingy? What is that? A what? Quadratic. What do we usually do to quadratics? We factor them. We F them up. So what does this factor to? You can kind of think of this as like a 2x squared minus x minus 1. What does this factor to?
2x plus 1.
So now we have a 2 sine x plus 1 and a sine x minus 1. And it's set equal to 0. So I'm going to use the zero product property just like we did in Algebra 1. We set that part equal to 0. So now I have 2 sine x plus 1 equals 0. And sine x minus 1 is equal to 0. So I need to get a trig function equal to a number. So sine x will equal what? Okay, sine x equals 1 over here. Good. On this left side, negative 1/2. So sine x is equal to a negative 1/2. Now, let's think about our unit circle. When does sine give me negative 1/2? We kind of just did this one. At 7 pi over 6 and 11 pi over 6. And when does sine x equal 1? At pi over 2. All right, at pi over 2. Now, do we need to add 2n pi to it? No, because I'm actually on this interval. All right, so those are my solutions. All right. Now, when I set a function equal to 0, what are we really solving for? I'm solving for an x-intercepts, exactly. So when I set a function equal to 0, I set y equal to 0. I'm actually solving for x-intercepts. That's truly what we're doing when we're doing this. Okay? All right. So now I have 2 sine squared x plus 3 cosine x minus 3 is equal to 0. What's wrong with this? They're not the same. They're not the same trig function. Which one can I solve? Or which one can I manipulate? The sine squared. Okay, so what is sine squared? 1 minus cosine squared. So that's what we're going to substitute in. So now I have 2 times 1 minus cosine squared. Okay, I'm just replacing it. And then plus 3 cosine x minus 3 is equal to 0. What would you highly suggest I do? Distribute. All right, so now we end up having 2 minus 2 cosine squared x plus 3 cosine, and then still minus 3 equals 0. Now what? Combine like terms. So when I combine like terms, I'm left with negative 2 cosine squared plus 3 cosine, and then what? Minus 1 is equal to 0. Now, you could factor it this way. I suggest you do something before you factor it this way. What would I highly suggest you do? Star fox it. Distribute this negative. All right, so we go choom, choom, choom. All right. So now, what do we have? We have a quadratic. What do we do to quadratics? We F them up. All right. So again, you can kind of think of this as like a 2x squared minus 3x plus 1. If we can factor that instead of x, it's just cosine. So what does it F up to? 2 cosine x minus 1 and cosine x minus 1. All right. So now I'm going to use the zero product property. So I'm setting both of these equal to 0. So I'm setting this equal to 0. I'm setting this equal to 0. So this left one, if I set this equal to 0, we're smart people, cosine x would equal what? 1/2. And then if I set this one equal to 0, I get cosine x is equal to 1. So let's think about our unit circle again. So when does cosine give me 1/2? Pi over 3 and 5 pi over 3. All right. So I get pi over 3 and 5 pi over 3 because cosine deals with the x. All right. All right. And then when does cosine equal 1? At 0 or 2 pi. I don't really care what you put, honestly. Now, do I have a domain restriction? I don't have a domain restriction. So what do we need to think of? We need to think of the period of cosine. So what's the period of cosine? 2 pi. So we're going to add 2 n pi's to these. Now, I just said I don't care about if you put 0 plus 2 n pi or 2 pi plus 2 n pi. Why do I not care?
It's the same thing.
Because it's the same thing. All right, it's going to cover each other. You following me? All right. So those are kind of my 3 solutions, or really it's an infinite amount. All right. I have is 2 cosine of 3t minus 1. 2 cosine of 3t minus 1. All right, so I need to get a trig function equal to a number. So what does cosine of 3t equal? 1/2. All right, so that's equal to 1/2. Now, this is the way I'd suggest you do it. Don't worry about the 3t right now. Okay, cover it up. Cover up the 3t. Think about when does cosine equal 1/2? All right, you follow me? So just leave it. Instead of an x, it's going to be a 3t, but just cover it up. So when does cosine equal 1/2? We kind of just did this one again. At pi over 3 and 5 pi over 3. So we get 3t equals pi over 3, and 3t equals 5 pi over 3. Now, what's the normal period of cosine? Because I don't have a domain restriction. So what's the normal period? 2 pi. All right. So I'm going to add 2 n pi's. However, have I solved for my variable yet? No, I haven't solved for my variable. Right now, I got 3 times t. So how do I start solving for t? Divide by 3. So we divide everything by 3. So when I divide by 3 on my first one, I get t equals, what is pi over 3 divided by 3? Pi over 9. Pi over 9. And then plus 2/3 in pi. All right. And then on my second one, I get t equals 5 pi over 9 plus, what's my new period? 2/3 in pi. And so these would be my solutions. All right. We got 3 tangent of the quantity x over 2 plus 3 is equal to 0. Again, we want to get a trig function equal to a number. So what are we going to do? Subtract 3 and then what? Divide by 3. So I get tangent of x over 2 is equal to what? -1. All right. So you kind of cover up x over 2 right now. So cover it up. So when does tangent equal -1? 3 pi over 4 and 7 pi over 4. All right, tangent's negative in the second and the fourth quadrant. All right. Now, what's my normal period of tangent? Pi. So what are we going to add to this guy? Plus n pi. Exactly. All right. However, have we solved for our variable yet? No, we haven't solved for our variable yet. So how do we do that? We multiply everything by 2. We multiply everything by 2. So when I do so, I end up with x is equal to, what's 3 pi over 4 times 2? 6 pi over 4, which simplifies to 3 pi over 2. So now I have 3 pi over 2 plus how much? 2 in pi. All right. 2 times n pi is 2 in pi. All right, and then x is equal to 14 pi over 4, which simplifies to 7 pi over 2, plus 2 in pi. Now, does this one cover this one? Yes, it does. All right, so we don't actually need that at all. All right. Now, there are similar questions to this, like this on the test. Some people like to do the I choose you Pokemon method, and they don't actually work them out. They just are like, oh, that one looks good. This one tricks people. Why does it trick people? Do what? Smaller. What does this period say it is? 2 in pi. All right, and what kind of function did we have? A tangent. We know a tangent has a period of what? Pi. However, what's my answer? 2 in pi. All right, and because it happens to be, it's of x over 2. Are you following me? All right, so these kind of problems, they trick my students every year because they just want to choose the right answer. All right. So on this one, I got secant squared x minus 2 tangent x is equal to 4. What's wrong with it? Do what? They're not the same function. So what are we going to do about it? A secant squared x is actually what? 1 plus tangent squared. All right. So I'm going to replace that with 1 plus tangent squared. And then I still have minus 2 tangent x. I'm going to go ahead and subtract 4 over. All right, so I'm going to set it equal to 0. Now what should I do? Combine like terms. So when I combine like terms, I'm at tangent squared x minus 2 tangent x. And then minus 3 is equal to 0. So what do I have going on here again? Quadratic. What do we do to those things? We F it up. You can think of this as like an x squared minus 2x minus 3. So what does this factor to? Tangent x minus 3 and tangent x plus 1 is equal to 0. So again, we're going to use the zero product property. All right, we're smart people. So I get tangent x is equal to what? 3. And tangent x is equal to negative 1. All right, I'm going to deal with this right one first. Okay, I'm going to deal with that right one first. So when does tangent equal negative 1? At 3 pi over 4 and 7 pi over 4. However, what's the period of tangent? In pi. So we're going to add in pi to it. Do I need both of them? I don't actually need both of them. Which one gets covered? The 7 pi over 4. All right? Because 3 pi over 4 is here, 7 pi over 4 is here. If I add pi to it, I get to the 7 pi over 4. All right, let's look at this next one. I got tangent x is equal to 3. So I think about that on my unit circle. Is it on there? It's not actually on there other than our certain dashes that we have normally. However, that's okay with tangent. Tangent's a well-behaved function. Because if I have x squared, how do I get to x? I square root it, right? Those are called inverse operations. True? If I have a tangent of something and I need to get to that variable, guess what I do to it? What's my inverse operation of tangent? An arctan. Okay, an arctan or an inverse tan. So I'm actually going to arctan both sides. So I'm going to arctan tangent x. So if I arctan that, I must do it to the other side. So I'm going to arctan 3. Well, if I arctan a tangent, I get to x. And then x is equal to arctan of 3. All right. Yeah, it's some number out there. I don't know exactly what it is. Something. All right. So we got arctan 3. However, what's my period? n pi. So we add n pi to it.
So we do that whenever it's not on the unit circle?
Yes. Mm-hmm.
But for sine, cosine,
There's your homework. There's your homework. You have a quiz tomorrow. You have a quiz tomorrow over 5-1 to 5-3.